Next up is Hearn's formula. Given a triangle with sides A, B, and C, no angles, just sides, so give the area of that triangle with these three sides is given by this formula. And this formula will be provided on your test if needed. So if I wanted to use it, if I want to use Hearn's formula, I'll give you that on the exam, where area is the square root of this S times S minus A times S minus B times S minus C, where S is almost the average of the sides. You add those, unit divided by 3 divided by 2. Straightforward really. Given the following triangle, area of this triangle, that would be the square root of S. Well, let's figure out what S is. S is the sum of the sides divided by 2. That is 11. 18 divided by 2. That's really a 9. So that will be a 9 into 9 minus 7, 9 minus 6, 9 minus 5, into any order that you like. You could plug this in your calculator and get the answer. That's really 9 times 2 times 3 times 4. Whatever that is, of course you could leave the answer like that, and that is fine. So you're allowed a calculator. You could plug that in. If not, you could leave it as it is. Not much to it really. So let's look at this first problem. It says a parallelogram has sides five and 7. So obviously this is the 5 and this is the 7. And one angle is 65. Well, we know the angle that's acute opposite of the smaller side would be the 65. Well, what we know, those are parallel and those are parallel. So if I extend this line a bit more, since this is 65, this is automatically 65. And I could figure out this angle, and once I know that, I'm pretty set. That's 180 minus 65. And what do they want us to find in this case? They want us to find the diagonal. So this angle is 115 degrees. They want us to find the length of the diagonal. The diagonal is that length right there. Whether I needed the 65 or not, because you could say, well, let's find this side. Okay, well, how does it work? Let's find the first length right there. If I look at this triangle, isn't that, call it D, isn't D squared equal 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of 65 degrees? And I could plug this in my calculator and figure out what that is. And what if I wanted to find the other diagonal? What if I decided, you know what, this is really the diagonal. And now I'm looking at this triangle. Wouldn't you say that that diagonal squared is 5 squared plus 7 squared minus 2 times 7 times 5 times the cosine of 115 degrees, and D will equal the square root of whatever that is. And let me plug those in my calculator and get this out of the way. And if I use my calculator, that's what I will get. So if they don't specify, I'll find both diagonals. The next problem up. A plane flies in a straight path for 2 hours. Okay, to avoid a tropical storm, the pilot adjusts the plane course to 12 degrees, by 12 degrees to the west of whatever direction they're flying in. So let's say initially they're flying at this direction. That's the direction of the plane. 2 hours, okay? To adjust, I'm guessing I need a bit more space here. Let me just bring this down a bit. So, at this point, to avoid a tropical storm, instead of going straight, the pilot adjusts by 12 degrees to the west. So if I go by 10 degrees, again, west is in this direction. So the new path, instead of running this, I'm going to move from this straight path by 12 degrees to the west. I'm exaggerating that angle a bit. Okay, I should have brought it even further down. Or to that. There we go. So in that direction, 12 degrees. Right? Instead of running straight, oh yeah, I can do this better. Here. Assume the pilot is running at this path. At a point, they run 12 degrees to the west. So now that heading is in this direction. Okay, much better. And flies for 2.5 hours. So this line is a bit longer. Again, it doesn't have to be to scale, but just so we can see it better. Alright. If the pilot maintains a constant speed of 500 miles per hour. Okay, for 2 hours. So this is 1,000 miles. And then 2.5 hours, what is that? 750 miles. After the course correction, because there's some storm right here. Right? The question is, how far is the plane from its starting point? Okay, how does this work? Well, if this is a straight line, that's 180. If that's 12 degrees, isn't this 168 degrees? 180 minus 12. And now, if I know the two sides of the triangle and the angle in between, can't I figure out what this is? Can't I simply say x squared equals 1,000 squared plus 750 squared minus 2 times 1,000 times 750 times the cosine of 168 degrees, and I could get x to be, if I plug this in my calculator and take the square root of both sides, that's how far it will actually be. And let me find that really quick. The plane will be 1,740.6 miles from its starting point. And if you want to get the new heading, you could. Normally they ask for that. The new heading, well, you could figure out how much off it is from that original course by calling this theta and using the sine, of course. Sine of theta to 750 equal the sine of 168 to 100. If they ask for that, normally they do, but I noticed in your homework they didn't. One more to go, and that's a lovely problem. Those are my favorite. Airport B is 350 miles from Airport A at a bearing of north 45 degrees to the east. Normally they say northeast, that means halfway through. So if I put a bearing and I cut it exactly in half at 45 degrees, there. Airport B is, so this is A, this is B. This is a distance of 350 miles. Not only that, I know it's 45 degrees starting at the north and heading toward the east. That's what that means. A pilot flying from A to B, mistakenly flies west at 150 miles for 20 minutes. Again, this is extreme, but so the pilot flies due west for 20 minutes at 150 miles per hour. Well, let's see. How are we going to figure out what this distance is? Distance equals rate times time. Distance would be, the rate is 150 miles every 1 hour, and I have 20 minutes. To convert minutes to hours, I need to get rid of minutes and hours at the top. Each 1 hour is 60 minutes. So that is 1/3 of an hour. That's 50 miles, basically. Again, this is extreme. When the error is discovered, how far is the pilot from the destination at the time when the error was discovered? They're asking what is that distance? Well, we know if this is 45 degrees, this is 90 degrees. So I'm looking at a triangle that looks like this. If you get out of the actual application and just draw what you have as a triangle, things will fall into place very quickly. This is 90 plus 45, 135 degrees. I don't know why I drew it so small. And let me move this. Put it down there. So, I know this is 135 degrees. I know this is 50. And I know this is 350. And I'm looking for x. And I could say in part A, x squared is 50 squared plus 350 squared minus 2 times 50 times 350, the cosine of 135 degrees, and x would be the square root of that. And I'm going to plug that in my calculator, and I'm getting this to be 383.76 miles. That's this distance. Of course, you could use 8 miles, 0.8 instead of 0.76, not a problem. Now, they're asking, what bearing should the pilot adjust the plane in to arrive at airport B? Remember, they're heading in this direction. So the actual bearing is going to be this much. Well, I could figure out what this angle is, right? By saying, well, I could say the sine, and let's call this theta. The sine of theta to 350 equals the sine of 135 degrees to 383.76. So I could figure out what beta equals. I'll get this to be 40.2 degrees. If this is 40.2 degrees, shouldn't we go by 180 minus? So the bearing should be 139.8 degrees from the east toward the north. So you know you're going to exceed the north, right? So start on the east, run 139.8 degrees toward the north. Well, if you're heading in the west and you head toward the north, you're going to end up lined up where you would like to be. And that would be it for this section.